So type 1 problems, these are Porter-Govan problems. Example 1, reference 6.1. Each arm of a Porter-Governor is 300 mm long, is pivoted on the axis of a governor. Each ball has a mass of 6 kg and a mass of sleeve is 18 kg. The radius of rotation of the ball is 200 mm when the governor begins to lift and 250 mm when the speed is maximum. Determine maximum speed and minimum speed and range and sensitiveness. So from the given problem, mass of the ball is small m, that is 6 kg. Mass of sleeve, the capital M, is 18 kg given. Radius of the ball is when begins to 200 mm when begins to lift, that means at minimum radius of rotation R1 is 200 or 0.2 meters, and at maximum speed is 250, that is 0.25 meters. Since both the arms are pivoted on the axis of rotation, so alpha is equals to beta, so k is equals to 1. To find minimum speed n1, we know that r1 is 0.2 meters for minimum speed. h1 is from the figure square root of 0.3 square minus 0.2 square from right angle triangle hypotenuse. So it's 0.2236 meters. So n1 square equals to the minimum equivalent speed, n1 square equals to m plus m upon m into g by h1 60 by 2 by the whole square. Since k is equals to 1, we use this simple formula. Substitute values of em, capital M, g is 9.81, 60 by 2 by the whole square, we have 126.5. Now to find the maximum speed. For maximum speed r2 is 0.25 meter, as we know. Now the height h2 is square root of 0.3 square minus 0.25 square, we have 0.1658 meter. The maximum equilibrium speed n2 is m plus m by m into g by h2 60 by 2 by the whole square, 146.9 rpm. So range is n2 minus n1, we get 20.4 rpm. Sensitiveness governor is n2 minus n1 all upon n2 plus n1 by 2. Substitute values of n2 and n1, we have 0.149. Example 2. Porter governor having the links 3 of 300, each link of 300 mm and a mass. Weight of the mass of the ball is 7 kg and weight of the sleeve is 540 newtons. Thus, the lower link is attached to the sleeve at a distance of 35 mm from the axis of spindle. The minimum radius of rotation when the ball begins to lift is 200 mm, and the maximum radius of rotation when the ball begins to reach its maximum is 260 mm. Find the maximum point between speed and range and sensitivities of the governor. Now here, since both the arms are not on the same link, so alpha is not equals to beta, so k is not equals to 1. K is 10 beta by 10 alpha. Now to find minimum speed, so r1 is 0.2, so h1 is 0.3 square minus 0.2 square, that is 0.223 meters. Alpha is r1 by h1, that is 0.2 by 0.223, that is 0.8968. 10 beta is AD by ED. ED is R1 minus 0.035, that is 0.165 meters. ED is square root of 0.3 square minus 0.165 square, 0.25205 meters. 10 beta is 0.165 upon 0.2505, that is equals to 0.6586 is tan beta. K1 is tan beta by tan alpha, that is 0.7366 is K1 K. Now therefore N1 is square equals to mg into W by 2 1 plus K by M into 1 by H1 60 by 2 by the whole square. M in G is 9.81, W is 540 newtons, it is already in newtons, upon 2 1 plus 0.7366 whole upon small m, that is 7 into 1 by H1, that is 2 to 3 60 by 2 per whole square. Simplifying and taking square root, we have 177.2 rpm. Similarly, to find the maximum speed, R2 is 0.26 meters. H2 is square root of 0.3 square minus 0.26 square, 0.14 times 7 meters. Tan alpha is R2 by H2, that is 0.26 upon 0.14 times 7, that is 1.7368. Tan beta is AD by ED. AD is R2 minus 0.035, that is equal to 0.225. ED is 0.3 square minus 0.0225 square, 0.1984. Tan beta is 0.225 upon 0.1984, 1.1340. K2 is all tan beta by tan alpha, that is 0.6529. Now therefore the maximum equilibrium speed N2 square equals to mg plus W by 2 1 plus K upon whole upon M 1 by H2 60 by 2 by the whole square. Simplifying and taking square root of N2, we get 211.7 rpm. Therefore range of speed is N2 minus N1, that is 34.5 rpm. Sensitiveness is N2 minus N1 whole upon N2 plus N1 by 2, 0.1774. Porter governor with each arm 330 centimeter. The lower arm is attached at a distance of 37.5 centimeter from the axis of spindle. The mean radius of rotation is 2.5 centimeter. Friction of 24.5 newtons. So L is 30 centimeter or 2.3 meters. Small m is 75 kg. So capital M 75 kg, small m is 10 kg. Mean radius R is 22.5 centimeter, 0.225 centimeters. Frictional force is 24.5 newtons. Now here, since they are both not on the axis of rotation, alpha is not equals to beta. K is tan alpha by tan beta by tan alpha. Now to find equilibrium speed, N, R is 0.25 meters, H is 0.3 square minus 0.225 square, that is 0.1984 meters. Tan alpha is R by H, that is 0.225 upon 0.1934 equals to 1.134. Tan beta is AD by ED. AD is 0.225 minus 0.0375, that is 0.1875. ED is 0.3 square minus 0.1875 square, that is 0.2342. Tan beta is 0.1875 and 0.2342 equals 0.8. K is tan beta by tan alpha, that is 0.8 upon 1.134 equals to 0.706. Therefore the mean equilibrium speed N square equals to M and M by 2 1 plus K M G by H 60 by 2 by the whole square. So values of EM, capital M, K and G H, and we have 82.6 rpm. To find the range of speed, if F is 24.5 newton, so N is mg plus F 1 plus K M 1 by H 60 by 2 pi square. Substitute values of F, we get N1 and N2 85.24 and N1 has 85. So N range is N double dash minus N single dash, that is 5.24 rpm. Coefficient of sensitivity F upon 2W by 1 plus KW, we have 0.028, that's 828%.